Hey y'all, today is kind of a weird title, equivalent division problems. Equivalent just means like the same. So look at this, you tell me, which of those problems seems easier to do in your head? 700 divided by 14 or 350 divided by 7? I think you probably said the second one, right? Because you can look at B and go, 35 divided by 7, I know that one, that's 5. So 350 divided by 7, that just must be 50. 700 divided by 14, I don't think any of us memorize our 14s tables. 14, 28, 42, 56, 70, 84. No, no. Okay. Okay, I think what the point of this lesson today, part of it, is to look at a problem and go, let's do something to both of those numbers, either multiply them or divide them, and make it easier on ourselves so we can do it mentally. Now, if you notice, look at A. Half of 700, look down, is 350. Half of 14 is 7. So if you do the same thing to both chunks of a problem, it's basically the same problem, right? In other words, if you divided 700 by 2, you'd get 350. If you divided 14 by 2, you get 7. Well, that's the same problem. This is the same problem as this. They both have the same answer, which is 50. So you can do that to division problems if you want to. So look at this. Which seems easier to do mentally? Ugh, I mean, come on. Look at that first one. No way. I mean, so if you see something like this, you're like, ugh, man, if I multiply that by 2, I get 15, 7.5. If I multiply a half by 2, that's a piece of cake. 15, that's just 15. I got the answer. So you can do that if you want to anytime. Anytime you see, you can see something giant like this, like that. You go, oh, man, I don't know, Well, just, you can notice both of those are even numbers. Just knock it in half, right? 400 divided by 12 now, right? Well, what if you did it again? What would you have next? It'd be 200, right? Divided by 6, right? What if you did it again? 100 divided by 3. You might think, oh yeah, that's 33 and 1/3. Well, there you go. It's a lot easier to do that. You just keep doing it if you want to. So, all right. Well, let's do an equivalent division problem for this one. I doubt most of us are going to want to go, divide by 16. I don't know my 16s tables. And you go, I hate those kind of division problems where they do that. And I don't even know 16s. Man, how do I know how many 16s go into 120? Oh, man, it's a pain, Well, then don't mess with it. Don't mess with 16s. Mess with something else. So go ahead, knock this in half. You tell me what you get with your new problem. 600, right? Divided by 8. You can do it again if you want to. Let's go 300. Divided by 4. Okay, we could do it again. They're both even numbers, right? Why not? 150 divided by 2. Man, dividing stuff in 2 is way easier than 8 and 16 and all that jazz. What's half of 150? 75. There it is. You got it. All right, try another one. What would you do on this one? 12.5 divided by 2.5. Ugh. Yeah, times it by 2, right? 12.5 by 2 is 25. Divided by, what's twice 2.5? 5. 25 divided by 5, 5. There you go. Move to the next problem. See, you're going to like some of these in your Saxon problem sets. Isn't it fun to have problems you just go, oh yeah, bam, bam, bam. Get those out of the way. Okay. All right. Let's try this, an oldie, but we're going to switch it up just a teeny little bit. All right. Missing number of problems with fractions and decimals. Well, you know how to do this, right? We got a number and we add it to 7 and we get 12. We're going to either have to add or to subtract something with 7 and 12. And in this case, you're going to have to subtract 7 from 12, which gives you 5. There's only one number. All right? The same, like I said, if a method works, I've said it before, if a method works, you found a method that works, then go ahead and use it. Even if the problem looks a little different, if it's the same type of problem, it doesn't matter if there's fractions or decimals. If a method works, you use it. That's it. Just do it again in these new problems. So let's look at this. D minus 5 equals 3.2. Oh. Okay, well, some number, take away 5, is going to give you 3.2. Well, with this number, is it going to be more than 5 or less than 5? Or more than 3.2 or less than? Obviously, it's going to be more, right? So what do you need to do to these two numbers to get the number? Add them, right? You probably see in your head that 5 plus 3.2 is just 8.2. Well, if you check it, you can check it. Let's go put this back in the original problem. 8.2 minus 5 should equal 3.2. Does it? Yeah, it does. So there's your check. Piece of cake. All right? Let's try this one. f plus 1/5 equals 4/5. Well, what are you going to do? Is this number going to be less than 4/5 or more than 4/5? It'll be less than, right? Because you're adding something to get 4/5. So what the operation you're going to use is you're going to subtract 1/5 from 4/5, and obviously the answer is 3/5. There you go. Okay. All right. Let's take a look at one more. Now this is the last type of problem we do. 3/5 times some number. We're not adding. We're multiplying. Remember, if you don't see any operational symbol like an addition or a subtraction between like a fraction or numeral or integer and what they call a variable, like a letter, then you're going to multiply. It just means 3/5 times n equals 1. Now what you're going to have to remember is the idea of reciprocals. Remember those? A reciprocal of, let's say, 3/12 would be 12/3. The reciprocal of 7/5 is 5/7. The reciprocal of 8 would be 1/8, right? Because 8 over 1 is 1 over 8. So all you need to do for these is just figure out what the reciprocal is of this number, and then that's what your answer is going to be. The reciprocal of 3/5 will be 5/3, and that's your answer. You can check this if you want. 3/5 times 5/3 should equal 1, and of course it does. 3 times 5 is 15, but 15 divided by 15 is 1. Boom, there you go. Okay. All right. Try the practice set. Oops, I gave away that answer. There are not too many of these, but let's go one at a time. And it's on page 229 to 230. So try A, pause it, and try A first. Yeah, I know, I gave it away. 15 divided by 1 is what I would do. So 5 divided by 1/3, just multiply the 1/3 by 3 to give you 1, and multiply the 5 by 3 to give you 15. It's the same thing. All right, pause it and try B. Ugh, what a mess. Yeah, I would do knock down 266 and 14 by 2. 14 is a piece of cake, then knock down by 2, right? Because it's just 7. Now the 266, what I would do is I would go, okay, because you can divide this. Half of 2 is 1. Half of 6 is 3. Half of 6, again, is 3. In other words, you just knock down each digit if it's easy enough to do. So 7n to 133 is 19. All right, pause it and try C. Okay, this one looks vaguely familiar, kind of, but you might, I know this, 8.2. Don't do that. Don't be tempted. Look at it. 5 times something gives you 3, about 3. So you should have estimated 5 times about 2 gives me 3, which would have told you that to get the answer, you subtract 3.2 from 5, you get 1.8. There you go. Okay, pause it and try D. Okay, again, looks familiar, but you're going to think, something's not right about that. Okay, the answer is 1. Something minus 1/5 gives you 4/5. You're going to have to add those together. 5/5 is the same thing as 1. Pause it and try E. Okay, the answer to this is 2 4/5. All right, now you might have looked at this and gone, oh, wait a minute, this is a mixed number. Oh, 4, how do I? You should have gone, okay, eventually you get to the point where you're like, okay, 4 minus 1 1/5 is my answer. Now remember, when you're doing this and you have 0/5 right here, you've got to borrow from here to 3, and this will turn to 5/5. 5/5 minus 1/5 is 4/5. 3 minus 1 is 2. There you go. Last one, pause it and try F. Obviously, the reciprocal of that is 8/3. There we go. All right. You guys have a great day. Enjoyed it, and see you next time. Take care.